Alright, this video is solutions to the quiz. Yeah, and essentially it's testing your skills of the product and chain rule and then an optimization problem. So we're going to find the differential. If I can find the derivative, I can find the differential. It's just changing notation here. So what I got to look at is what are the functions, okay? And what do I have? I have product, I have quotient, is there composition? I have to see what I have, okay? So first thing I notice is I have two functions. I have 4x and I have sine a squared of 5x. So I have two different functions. So if I have two different functions, I have to do the product rule, okay? So we had some form of ABA there. So A is going to be your 4x, B is going to be the sine squared of 5x. So we have to use the product rule. Okay. So dy will be 4, derivative of the 4x is just 4 times the second function. Okay. Now the second function is a composition. There's actually three functions. The outermost function is square. Then the middle function is sine, and then the innermost function is 5x. Okay, so in the context of doing the product rule, it's the derivative of the first function, which is the 4x, which has a derivative of 4, times the second function, plus the first function, which is 4x, times the derivative of the second, which is the sine squared of 5x. So what we can do is we can treat the interior as the sine of 5x, which is actually a composition in itself, and then the outer function is the square function. Okay? Derivative of the outside is 2x, derivative of the inside is cosine 5x, and then by the chain rule times the derivative of the innermost part, which is the 5x, which has a derivative of 5. Okay? So then the inner goes into the place of the derivative of the outer, so the sine of 5x gets replaced into the x here, and then multiplied by cosine of 5x times 5. Okay, so there is the derivative of that, and since we're doing a differential, we're just going to swap out the f prime notation with dy and dx. Okay, I'm not really interested in simplifying it. I just want the very basics. Can you do the product rule and the chain rule? Okay, so this one's probably a little bit harder than the other one that we have, but we're going to go ahead and look at that one as well. So this time we had f of x is equal to cosine x times sine squared x. And this one again is a product rule because we have cosine times sine squared. So the derivative of cosine, the first function, is minus sine x, times the second function, plus the first function unchanged times the derivative of the second. Well, the second is a chain rule problem. The inside function is sine, who has a derivative of cosine. The outside function is square, x squared. The derivative of that is 2x. So we stick the sine in and place the x, and then we multiply by cosine x. So then we have 2 sine x cosine x. Okay, and then there's our differential. Again, not interested in simplifying it, just can you do the product and the quotient rule together on this problem. All right. The other problem on our quiz, we were looking at an optimization problem. So we wanted to minimize the surface area of a rectangular box that had a volume of 100 centimeters cubed, and then the width was 4 centimeters. So volume is going to be length times width times height. So substituting what we know, 100 is equal to length times width times 4. The surface area, we'll go ahead and draw a picture. So here we'll draw a rectangular box, and we'll go ahead and label our length, our width, and our height. Okay. So we have a bottom and a top, which are dimensions length times width. So we have the bottom here and the top here. And there's two of them. Plus 2 times 4 times W. So that's this face here and this face back here. Those dimensions are 4 by W, and there's two of them. Plus 2 times L, or 4 times L, the order doesn't matter. So that's this face here and this face back here. Okay? So that is our surface area formula, and that's what we want to minimize. However, we have a problem because I have the variable of length and width, so that's a problem. If I want to minimize, I have to get it all in terms of one variable. Now I have my secondary equation over here, and I can solve for the length or the W. Notice that this is multiplication by 4. So I shouldn't subtract 4 from both sides of the equation. I should divide by 4. So don't tell me length times width is 96. It's going to be 25. Okay. Alright, so surface area. We can factor out a 2. And it's 2 length times W, 4 times W, 4 times L. Divide both sides by 4 in our secondary equation, and we have 25 over L is equal to W. It doesn't matter if I solve for L or W, I'm going to get the same answer here, so that'll be just fine. Okay, so our surface area is equal to 2, and then length times W is 25 over L, plus 4 times 25 over L, plus 4L. Alright, another thing to mention here, these L's cancel out, so I'm not going to have something like 25 L squared or over L. Okay. If you want, whenever you're multiplying a number times a fraction, you can always make the number, the L, make it a fraction by making it L over 1, okay? So then that's going to give you 25L over L. And those L's will cancel out just like that. Okay. Let's go ahead and simplify inside there. So your surface area is going to be equal to 2, and then the L's cancel, so we just got 25 plus 100 over L plus 4L. And we're going to go ahead and take the derivative. So surface area is going to be equal to, there's 2 on the outside, the derivative of the 25 is just gone, and we got 100 L to the minus 1. So when we take the derivative of that minus 1 is going to come out here, and it's going to make it a minus 100, and then we're going to subtract 1, and we're going to have L to the minus 2, which is just going to send it down to the bottom. So what you're going to end up having is negative 100 over L squared there. Okay. So negative 100 over L squared plus 4. And we're going to set that equal to 0 because we're looking for horizontal tangents, and that's most likely where we're going to encounter minimums and maximums. Okay? So what we're going to do is, you can divide by 2. Okay? And then after we do that, we'll subtract 4 from both sides. So subtract 4 and subtract 4 from both sides. And then after we've done all of that, then we're going to clear the fraction. We're going to multiply both sides by L squared. We got negative 100 is equal to negative 4L squared. We'll divide both sides by negative 4. Divide both sides by negative 4. And we'll have 25 is equal to L squared. We'll take the square root, and we won't do the minus 5 because this is the length, and usually we don't want negative lengths. And the last thing I got to do is I got to make sure, well, is this actually a minimum? So I put 5 here, and then I got to test a number in the first derivative. So I could test like 1. So if I test 1 here, I'm looking for if it's positive or negative. Well, you can have negative 100 plus 4, negative 96 times 2. That's going to be negative. So what that tells me is up until 5, we are decreasing. Then I can take a number like 200. 200 squared is a big number. So if I had 200 squared, that's going to make this basically very small. And 4 will overcome whatever negative that is, so it's going to be positive. So we went from decreasing to increasing, so we have a minimum there. And all we got to do now is just pop in the 5 in for the L, and we find that the W is also 5. So we end up getting a square base that's going to give us this volume of 100 centimeters cubed. And if we want to put our units on here, this would be both in centimeters and centimeters. And we would have a square base. Okay.